Welcome, welcome. For those who have just joined, we are giving everyone a couple more minutes because, as always, it's taking a busy day. Meetings are overshooting, being on time, not so easy. So we'll take another 1 or 2 minutes, and then we'll get started. Make sure everyone gets a chance to join. So we'll be back in a minute. Okay, it looks like we have the majority of everyone who signed up to the webinar here. So let's get started. Thanks everyone for joining us on this rendition of our monthly webinar. This webinar, we're going to start off going through a couple of industries in particular that we've been working in. And we're starting with the roof shingle world, roofing in general, but especially the roof shingle world, which we first got to know in some 3 years ago on our very initial pilot. And since then, we've had the opportunity to look into additional manufacturers and additional products within this range. And it is a fascinating range, which has a number of properties which are unique, but at the same time, many of them are also shared across other industries and are worth shining a light on. So whether you are in this market yourself or whether you are from somewhere else, some properties or some aspects of the challenges here will be quite relevant to you as well. Now, on the call here with me today, I have Mike, who's our sales and creative lead. We have Hena, who might be the one who reached out to you on LinkedIn or elsewhere, who's responsible for our marketing and PR. And we also have Xandra with us, who's our project manager. So if you're already working with us, you will probably have had a touch point with her already. The point of this is to hopefully be somewhat educational or interesting to you, but we would prefer to not have this as a lecture or as a purely me or Mike or Hena talking and telling you all about how what's going on and how great we are. Obviously, we think we are pretty great, but that's not the main point. Instead, what we would prefer is an actual conversation. And to that end, there is the opportunity to interact and to submit questions, and that is what we really prefer to do. So at any point, no need to wait for any Q&A at the end. Please make use of the Q&A function to submit a question, and that will be flagged to us immediately, and then we can for a given section that we are currently talking about, or we might bring it back later to the Q&A if that's more suitable. But in general, that's the idea. So if you do have any question or any thought or objection, also very fine to receive these. Please just put them in the Q&A box and let us know, and then we will address them right away. All right. So I see a couple more people have joined. Welcome. We're just getting started. You haven't missed anything yet. So today we'll be talking about roof shingles. But let me begin with where we are heading, or why we are talking about all of this in the first place. We're talking about all of this because there is a technology out there that is promising a lot, and that has a lot of potential, which is why everyone is looking at it, right? We've been talking about industry 2.0, 3.0, 4.0, and now 5.0. And then as of this year, the physical AI is all the rage. But where it is all heading is towards automation, is towards using some of the latest tools that are available, and most importantly, the artificial intelligences that are becoming more and more capable to make production better, to make production lines more efficient, to streamline processes, and also to make progress on one of the last frontiers, which is to automate the quality control, which is traditionally very labor intensive and in many cases a rather tedious, menial, and difficult work. And the promise is clear, right? If it works and you succeed in automating, paradise wonderland awaits, right? Ideally, if you can have full visibility of your product throughout the production line, you should be able to increase your yield. Your scrap should be going down. Your throughput should be better. Maybe downtime will improve. And we're not even talking about any of the knock-on effects of having better products, higher quality, less recall, better trust in your customers or contractors or suppliers who are buying off you, and so on. So that's it's very clear, right? If it works, it's going to be awesome. Unfortunately, the reality more often than not looks closer to this, right? You end up in what we call research hell, or some call it also pilot purgatory, right? Reality is it's so much more difficult than it first looks, right? And why is that the case? Why is it so difficult? And that has to do, in many cases, with the realities on the line. And here we are getting closely, in this case, into the parameters that we see in the shingle manufacturing world specifically. This is mirrored in many other settings as well, but it is a particularly interesting one, and it stands somewhat exemplary for what we see in other industries as well. So if we look at the production reality in the roof shingles manufacturing world, is that the production of the shingle itself is extremely fast, right? And the shingle is not produced in discrete units. It's actually one continuous product. So you're starting with a glass fiber matting. There we go. You're starting with a glass fiber matting that forms the base of it all, and you layer different additional materials on top of it, most importantly asphalt, and then various granules. You cut out components, you apply additional zones, paint elements. There is some complexity in the compositioning of the various layers of these asphalt pieces, and yeah, you're dealing with heavy material, right? And most importantly, you're dealing with asphalt, which is notoriously terrible as in difficult material to work with. Why? Because you have to work it while it's hot, and it's very sticky, it's very gluey. It's also very glossy, but also light absorbent at the same time, right? So, and you are applying not a beautiful finish to it that has a uniform coat, but you're applying sand and granules to the top of it. So that yeah, generates a product that is visually very difficult, produced in an environment that is very challenging. But you still have to do some quality control, right? So how do you do it? And in the cases that we have been working on, it's usually done manually. There are a few parameters that can be checked with dedicated sensors, but the most important parameters that you're looking for are definitely done manually, and these are done manually on sample testing. So with all of the manufacturers we've been in conversation with in this space so far, it is interval testing. And the interval testing is determined by the speed with which a human can pull shingles off the line and how long it takes them to go through all of the parameters. And that usually lands you somewhere in the 20 to 40 minutes, going from collecting a sample to checking and registering and sending whatever signal that there might be something wrong to the production line, right? And that means if you have a production line that moves at the speed that we are seeing here, which can be several meters per second or feet per second, depending on where you are. In any case, it's extremely fast, right? By the time you have detected an issue, with a delay of 30 to, let's say, 40 minutes, you will have produced hundreds, if not thousands, of additional products that very likely carry the same defect. And what that means is that yeah, there's a lot of possibility of missing out on defects, missing out on spotting these defects, but at the same time, there is opportunity that if you could check it, right, then it would be great. Then you could prevent this from happening earlier. But it's not easy, right? So if, yeah, but the opportunity is there, and the reason to try to make it work is clearly there, right? But this environment, I pulled out this little video that I found here. I think this was taken at I'm not sure which plant it is. It may have been a GAF plant, actually, going from the beginning, right, to the end. Ah, yes, GAF indeed. If you get it to work, it's fantastic. But look at this conditions right here. This is the product. This is the kind of shingle that would be inspected, and this is the production line. Usually, when we're talking about machine vision solutions, the showcases that you will find online tend to be in very pretty factories, very clean, spotless, where there's not a tar pit or something that looks like this, right? This is a fantastic example of some of the difficult conditions that you might find in the shingle world. And that's where we get to, this is why I think this might be interesting for some of you who are not in this world, but you might have similar complexities in your production line. Maybe not bitumen, maybe not asphalt, but also environmental difficulties that would otherwise might make it difficult to get a machine vision system up and running. So this is the kind of product that we are looking at. Again, this we pulled from GAF's website, outlining some of the details that they are looking at, and all of this is part of the quality control parameters that need to be inspected, right? So if you want to do the inspection of these products, you have to do a full inspection. What the human inspector does is not just inspect a few of these parameters. Obviously, they're doing all of it, which means there's a lot of complex parameters. The dimensions have to be correct. The location of things like the different lines here need to be correct. The alignment of these two layers need to be correct. The distribution of the granules has to be correct. Here it should be a bit darker than in this area. There's these components on the backside. The release tape needs to be in the correct position. It needs to be sticky enough, but not too sticky. You have to check whether it has delaminated. There is these, what is essentially a kind of layer of glue blobs, which need to be in the correct position, the correct length, the correct dimension, and so on. All of this needs to be checked. And if you want to automate it, then all of this also has to be accounted for, right? And all of that with this kind of product. So that means it's quite difficult to get there, right? And we've had this slide here quite useful to explain why it is so difficult to get this to work in the machine vision world. It's because of all of the, wait, I have to remove my paints from previous clear. Here we go. Every time you have a new variant, technically you run into the machine vision bottleneck, right? Because for every type of product and every time you change a little bit, you have to do an additional training and you have to collect all of this data again. And the more complex and the more non-uniform and chaotic a product is, like you saw with the shingles, the more difficult this becomes, right? And then it can very quickly become this uphill battle. This is a graph that we've been using for a long time now, but it really outlines the main problem that we see in a lot of manufacturing settings, and the shingle world is really a prime example of this, which is you may get to something that is very promising relatively quickly. Let's say something like an accuracy of about 80%, but then to move from this 80% to 100%, of course, 100% is quite difficult as well, right? It's impossible. We're talking about 99.99%, right? Getting there is an exponential increase in difficulty. Why? Because usually you would have to add so much more data. You would have to collect so much more data. Essentially, you need what we said here in the previous one, right? You would need an exorbitantly large curated data set to account for all of the different variations. Because usually machine vision follows the chunk in, chunk out principle. If you don't have enough representative data to teach the system, it just won't know what is good and what is bad, right? And that's a huge problem. And that means the more variations you have, and this is something that I haven't mentioned yet, these are not, singular products that are being produced in the shingle world. They have lots of variations, lots of different colors, different details. There is a very large variety of these shingles, which may at first glance look very similar, but actually they're quite significant. And for machine vision system, all of this is a nightmare, right? Or it looks different from what I've seen before, right? So you have to teach it per variant, per color, per difference in product code. And for each time you have to collect all of these samples, and it very quickly becomes very difficult to make this economically viable.
Yeah,
Like
just to just to jump in there, even if you collect the right data specifically for these type of more organic products, like you were describing earlier, like the quality rules aren't quite this or that. It's kind of like a bit of a gray area where you're trying to define rules that a human can easily understand. But if you're going through these kind of conventional systems where it's black or white, it's very hard to define them for these types of products. Meaning stuff like the paint lines, it's not clear white or not white on the product, for example. There's kind of like a hard road to explaining exactly what you're looking for to a conventional system.
Yes, indeed. Thank you, Mike. That's a very good point, because it's another very good example also of a type of product where the quality parameters are very easy to understand for a human, but very difficult to parse into machine language, basically. So like Mike just said, to a human, it's quite clear to say, look, this paint line needs to be visible enough so that whoever is actually installing it on the roof can clearly see where the upper and the lower limit is. Right? That it's clear for a human, right? A human, like, yeah, okay, I can see it. It's clear enough. But try to explain that to a system, right? Because you have to actually parse that into density of the paint or continuousness and so on. And again, traditionally, that just means you would have to have enough representative samples to actually accomplish this. And that can be quite difficult. But okay, so we've now talked quite a bit about all of these difficulties and why it's so hard to do it. How do you solve it? And that's where we come into play, right? How do we solve it? We solve it with synthetic data. So this is our shtick. This is what we are all about. And this is a technology that we are successfully applying in the roofing world. And what it does is it allows us to cut down on this requirement of having these crazy data sets, which translate into someone having to do it. Right? When we say you need lots of data, it means someone has to collect it. Someone has to sit down, take pictures of it, label it, and provide it, and do the training. Right? And that is what we are cutting down on. So usually the way I always explain it is that our system really mimics the way a human works. Right? If you have a human worker, you explain it in natural language, you explain what you want to inspect, and you show a couple of examples, and after some time, the human goes, got it, I understand now, right? And what has happened inside the brain of the human is imagination, is extrapolation, is semantic understanding of your principles and the ability to apply that to this type of product. And even if tomorrow the human sees another product that looks nothing, or not nothing, it should still be roughly similar, right? But with different color variation or slightly different parameters, he won't flag everything as a false positive, but will be able to translate that into accurate inspection nevertheless. So that's the magic that powers it all. And we've been applying this to different cases now, using different approaches, either being a standalone system or an inline system. This is actually a graphic that if anyone from GAF joined us, they might find familiar, because actually one of our oldest graphics here from the very beginning as we entered this industry, looking at a shingle that's rolling through. And what we experienced with GAF is still holding true in with other manufacturers in this space, that there's always these two modes, either a static inspection system that can be used for ad hoc testing, lab testing, verification, and so on, or also on the line. And on the line is, of course, more challenging because you actually have to have the hardware and the software capable of doing the inspection in real time. And there's that's a lot of advances. We're very happy to see, especially the hardware, make a lot of advances. Most recently here, you can see one of our more recent stationary inspection systems here, scanning one of the shingles from one of our customers. But from the inline, unfortunately, we can't show you anything because that's inside the actual production line, and that would be covered under NDA. But the point is, especially with recent advances with the hardware, we can actually capture the data at speed. And if we can capture the data at speed, it means we can also do the inspection at speed, right? And here, again, our approach allows us to have so much training data available to the models that we train that we can make them extremely efficient and extremely fast. So as long as you have a decent edge device, we can be very close to real-time inspection, let's say a couple of seconds of delay, essentially, to cover most of these parameters that we have been talking about. Most of these parameters that, as an example, right, you might have in this kind of shingle. Mike, did you just come off?
Yeah, no, I was going to say, you just showed the standalone inspection station as well. I think the benefits of having the inline inspection are quite obvious and maybe might trump the standalone station a little bit. So maybe just elaborate a bit for people why a standalone station can also be beneficial in terms of like consistency in inspection and also still speeding up inspection time, even though you're still doing that pulling off the line and inspecting maybe one shingle every now and then.
Yeah, indeed. So yeah, as you said, the advantage of having inline inspection is quite obvious because you can actually monitor properly every single shingle. Well, in the case in the shingle industry, it's not discrete shingles yet. It's a continuous ribbon of product that then has to be cut. But you can continuously monitor the parameters, and then what I said earlier, right? Having this delay between inspection result and taking action on the production line, that can be eliminated, and that means you can indeed arrive in paradise wonderland of identifying defects before they happen, right? And allows you to take action early. But it still might make sense to have the standalone inspection station as well, because then you can do the cross-checking. I mean, we are obviously aiming to be as perfect as possible, but we still need to do verifications. We need to make sure that whenever there's a new product, something that needs to be onboarded, a new type of design, a new type of parameter sets that are part of a new variation has to be onboarded. We have to verify that our measurements are exactly the way that the manufacturer wants to measure it, and that is very difficult to realize on the production line, and allows for verification as well. Right? So both make sense, but the true value is clearly from the inline inspection, because you get the real-time inspection. Once you have done all of the inspection, all of this is visible in a dashboard. In this case, this is from a different customer, actually. This is from the aerospace world, where we are also applying our technology. Very difficult product, very different. These guys are producing their things in a clean room, which is a very different type. But then conversely, they are looking for sub-millimeter defects, not the much more macro parameters that you're seeing in the Shingle world. But they have graciously allowed us to use screenshots from the actual system in production from their case to show what it looks like. So in their case, you can see how whatever we found will be visualized. We show where it is found on the product. So if you have in the Shingle world, if this was a standalone Shingle inspection station, we would have a replica of the Shingle here, the actual scan of the Shingle. And then we show you exactly what we found, what kind of issue is here, what kind of measurement is wrong here, and make that available to a human operator to review, to comment on. There's also, of course, the ability to provide feedback and make the system better over time. Or if you prefer not to have it as a live system, this will be collected, and then we review it together at a later point and see if we want to do another iteration of training. Right? Perhaps this is also a good moment to emphasize that the system, or our system, can be implemented entirely on-prem. It doesn't have to be a cloud-connected solution. So the entire inspection and training, everything can be set up to be happening entirely within your network. Right? You'd need some compute to do the training on site, of course, but this is very moderate. Right? We're talking about a machine that has a couple of GPUs. Most manufacturers already have this kind of infrastructure, either locally or virtually, so it shouldn't represent a problem. But we see a lot of interest and a lot of demand that these solutions, especially in the QC space, which is some of the most sensitive data, must not be cloud connected, and that's what we are setting up our system to do as well. If you're curious to see a bit more about what it actually looks like to have our system in place, again, this is in the case of our aerospace customer. This is what it looks like when you have it in place. Here you get your overview. You can see what has been happening statistically, what kind of defects were the latest, how do they cluster. Right? Some of this is extremely valuable for bringing it back to your production line. In their case, it's discrete panels that are being inspected end of line, but you can imagine this to be slightly differently set up, but the results would be equally representative if you have it at a continuous product that is being scanned, and you just get accumulative reports of the parameters, how they are changing. What we can see also in the Shingle world, and this might apply to other industries as well. So again, for those who are joining from a different industry, the Shingle world changes the production line from one type of shingle to another sometimes. And we can track how the change from one type to another corresponds with the appearance of a certain type of defect that tends to be more prevalent when the switch is from product B to C than if you change it from B to F. Right? And that is an interesting insight that you can translate into trying to schedule it in such a way that the transitions are sequenced to minimize the kind of defects that we are seeing. Right? But you wouldn't be able to know this kind of stuff if you only have offline inspection, if you do only your sample inspection. This is the kind of insights that you can unlock if you have continuous reporting, if you have live inline inspection. But to return to what it looks like, here actually, I like this overview as well, because you can see how many different types of defects we are checking at. These are all different parameters, different types of defects, different rules of clustering, how many are allowed to be in what area, what type and what class per product changes here as well. Some products have a larger allowance for a certain type of defect, others have less. All of this is accounted for and then made available in a full report. Obviously, this report can also be kept completely digital and passed on to whatever IoT system or PLM management system you might have to actually translate that into an action on the production line, like a rejection or alerting an operator to make changes. All of this is also accounted for in the system, right? And equally, I'll just skip a little bit here. You have the ability to onboard new products. And this gets us to another key capability of our system and our approach, that you can continue to onboard additional products. So if you have a new variation, a new type of color, new parameters, maybe you have a new customer who has different preferences, all you'd have to do is you set up a new product group with us, or a new variation. You specify what kind of specifics you have for this specific variation. You run one scan, let's say through the stationary system, and then we have everything we need to do the training. Again, let's say a few years ago, a lot of this would have been pretty hands-on on our end. So we operated more as a outsourced AI expert team, where you send us the data and then we do a lot of hands-on usage of our tech stack to synthesize the data, train it, and so on. By now, we are at a point where we have automated this technology to such a degree that it's almost entirely automated. So we can actually implement this. And if you check out our website, you will have seen us talk about Zelia quite a lot. We can implement this in a way where it's either very little input from our end, but we still take care of everything, or it could be also entirely on premises for you, and we don't get involved at all. You just handle everything with Zelia. You do all of the training by yourself on premises with the automated agent that walks you through the entire onboarding, training, and the solution implementation. So that's, I think that's the big overview. If you wanted to have a look at what differentiates us, then we are able to deal with the difficulty that you might find in an industry like the Shingle world. We are able to deal with the non-uniformity. We have a system that can continue to onboard with the large variation that you can see, and we will make sure it continues to work indefinitely, right? And that allows you to scale at a different degree that you might otherwise see. What this also unlocks, and this is where we have not even, we're far from seeing the end of the journey, is it unlocks the ability to truly saturate a production line with inspection stations. So if, again, we're looking at the Shingle world, we have yet to fully saturate a production line and be there at every stage. But even a few stages are already extremely instructive. If you can capture what is happening at the different stages, you can bring that insight back to the production line and fine-tune it, right? Because you can cross-correlate. You can see, okay, whenever we see this anomaly or this problem here, it translates into potential defects or errors in the sizing, cutting, and so on later on. And again, why is that unlocked? Because it is unlocked due to our ability to work with very little input data and to synthesize. Because otherwise, once again, right, returning to this slide, if you have a product that looks different at different stages, you would have to do all of this training every time, for every variant, at every stage, over and over again, and that just becomes really, really difficult. Right. Mike, have I forgotten anything important? I think this I pretty much outlined already. I think that was the main learning points we have from the roofing world, right?
Yeah, I think it's like some of the common themes, which I think you've touched on already, is just the like real-time inspection. How close can you actually get to real time? So the real time is a bit of a touchy subject in these types of solutions. Like, is it actually real time? But maybe just like one question that came up when Hannah and I were kind of advertising the webinar and reaching out to people. That seemed to be a common theme. Like we shared the deck to some people, and the question came from real time in terms of the reporting as well as the inspection. Is that like completely real time together? Like, are you getting the reports in real time? What does that kind of look like as the inspection is going on? Like, can you view the reports in real time, basically, for each product coming through, or how does that data look on the platform? Maybe you can talk about that a little bit.
Yeah. Yeah, and also in connection to that, how long can, you know, what's the logistics of it? How long can you store it, and so on? So on the how real time is real time, and it depends to some degree on the hardware that you are implementing. But usually the limiting factor is the speed of the model, right? How quick is it? How efficient is it? And here we are usually operating in the seconds range. So to go from the analysis of a frame to an actual result across all of these parameters reported in the dashboard, we're talking about seconds, right? And then it's just a question of how quickly can you capture these images, put them in the process them and report them, and that how quickly does it move through the network. If you have a decently set up network, yeah, it should result in a few seconds. So it should not be more than, let's say, 10 seconds maximum to go from the capturing of the shingle as it, or the shingle ribbon as it goes through the inspection station to the reported results on the dashboard. So it's technically not live. It has a few seconds delay, but it's certainly a lot more, a lot closer to real time than having a 20 or a 30 or 40 minute delay on it. And then in terms of storage and so on, that's just totally up to the customer. So we can set Spectron up to store everything, including the raw data, indefinitely if you have enough storage, or we compress it and we just extract snapshots and have a representative, statistically representative sample available for you if you want to roll back virtually what has happened on your production line. You can do that.
Also, just like just to clarify the whole end-to-end service that we kind of offer, all these components like the server recommendations, like the PC for processing on site, all these types of things. Although we don't innovate them, we do help you source the correct hardware for the setup, and we will help you design the full hardware setup and help you get it set up on premise, so you don't have to be doing this stuff yourself and try to do the research yourself and figure out what's best for you. That comes included in the full package.
Very good.
And that's something that,
yeah, very good point, Mike. Because the hardware is, of course, an important component of all of this. And while a large challenge is in the software as well, making a machine vision that can, a system that can deal with the difficulties of these kind of products, it's also important to have a hardware system that can cope with the environment. And here, we've now been in the business for a while, and we have fantastic connections, advisors, suppliers, partners. So we can build systems that are extremely rugged, including whatever you might need. Most importantly, in this case, we see air blades being extremely effective, keeping the optics clean, keeping the sensors clean, but also things like vibration dampening and so on. All of this is important for long-term operation, but all of this can be solved with the proper engineering. we also see this definitely as a partnership approach, because manufacturers see, or they know their production line the best. They know the conditions the best. And the best hardware installations for us are the ones that we have put together in close collaboration with manufacturers, where they tell us exactly what the conditions are, what their experiences are. And that, together with our in-house mechanical engineering teams, yields the best results, and having very robust systems that can do the inspection without needing much maintenance or any maintenance at all.
I think you covered the one question that was asked in the Q&A about messy environments and how you handle them. I think you touched on some point there.
Yeah, exactly. Yeah, it is, and this is, that's why we chose this industry or this is one of the reasons why we chose this industry for the starting of this Zetamotion in different industries webinar chain. The next one we haven't decided yet, might be aerospace, might be glasses, might be a different one. But that's why we chose, one of the reasons why we chose this one, because it's so representative of a difficult product in a difficult environment. All right, we still have a little bit of time. So if you haven't asked any question yet, feel free to do so. Bottom right, little dots, and then the Q&A. Let's see. Yeah, other topics that have been covered in webinars is a question here, and what's upcoming topics. We've gone through a couple. Quite popular was addressing some of the common myths of what it's like to do machine vision inspection, with some tips and tricks, or best practices, what to look out for, how to get started. The most recent one in January was an outlook, kind of reviewing the landscape, what's out there currently, what is the trends, what to expect for the coming year, mostly technology-wise. We're talking a lot about agents, of course, and introducing Zelia as well on the January one. But it's a variation of themes. Usually it's centered around a central question or topic. Another one that comes to my mind is how to deal with the supplier chain and the differences in opinion in inspecting, which is a very fascinating topic. So this is what we call the defect consensus problem, where you have various inspectors in the outgoing and incoming inspection, and they don't quite agree with each other how to handle that, and how a system like ours can actually be a neutral arbiter in between the different parties, and allow the reduction of friction between people in the supply chain. Because once you all review one uniform conditions inspection result, and you agree on how to measure X, Y, Z, then it's the same across everyone. And then you don't have to go back and forth and argue and handle recall and so on. That would be another example of a webinar. And as I said, we are planning to have a line of webinars, the next coming ones, maybe 2 or 3 more, where we highlight work in a given industry and what might be some unique challenges, and how our approach applies to that particular industry, and why it might be interesting to look at. And also, of course, the idea is that anyone who joins from a similar industry, or an industry that shares similar pain points, might get something interesting out of it. see, do we have a few more questions? Uh, 6 more minutes, I believe. Right, we'll give everyone another minute if there's anything that might be interesting to you. Not sure where everyone is coming from, what industries, if this connects to you or not. Could be interesting to hear. All right. In that case, I think we'll close it for today. Thank you, everyone who made it to join us. If you have any further questions or there's anything you'd like to hear in addition, do not hesitate to reach out. You can always get in touch with us, send us an email. You can reach us via contact@zetamotion.com or find us on LinkedIn. Very happy to answer whatever we might not have answered today, or things that might come up for you later on and you didn't think of today. That's also fine. Thank you very much, everyone. Bye for now.